Hello friends, in this video we are going to see about capacitor and how to find the total capacitance value in one circuit. And in our previous video we discussed about resistance and how to find the equivalent resistance value. And in this video we are going to see about capacitor. So first of all, the capacitor, the property of this capacitor is used to store the electricity. So the property of capacitor is to store electricity. And the definition of this capacitor, that is equal to charge divided by potential difference, that is Q divided by V. So if you are considering the parallel plate capacitor, so parallel plate capacitor means this is parallel plate capacitor. If you hear dielectric or any other medium, so this will act as a capacitor. This is a parallel plate capacitor, so it has some charge with respect to other, and the potential difference across the two plates. So it will provide the capacitance amount. So the definition here is C is equal to Q by V, where Q is equal to charge, V is equal to potential difference. So this is the definition of this capacitance, and the unit of this capacitance is farad. And the equation for finding the capacitance in parallel plate capacitor is the C is equal to epsilon A divided by D, and in any medium this epsilon is equal to epsilon naught epsilon r, and epsilon naught is the permittivity in free space, and the amount of epsilon naught is 8.85 into 10 to the power minus 12, and epsilon r is permittivity of that medium, and A is the area and D is the distance between that two plates. So this is the parallel plate capacitor capacitance value. By applying each value in this equation, we can find the capacitance value. And now we can find the total capacitance value in parallel and series circuit. And if the capacitors are connected in series, so the Q on the three capacitors are same. So when the capacitors are connected in series, the Q charge across any capacitor is same. So Q value is same across these three capacitor, but it has different value, V value. So the overall voltage V is equal to V1 plus V2 plus V3. So the voltage V is equal to V1 plus V2 plus V3. So now we are going to find the total capacitance, that is the reciprocal of each capacitance value. So 1 by C, that is equal to 1 by C1 plus 1 by C2 plus 1 by C3, and taking LCM and solving this, we will get like this, and the equivalent or total capacitance, that is equal to reciprocal of this value. So the equivalent capacitance or total capacitance, that is equal to C1 C2 C3 is divided by C2 C3 plus C1 C3 plus C1 C2. So this is the equation of total capacitance in serial connection. Next we see about the capacitance in parallel. So in connected in series mean Q is same for all C values, V is different. So just opposite to that series connection, Q is different across each capacitance here, and the voltage across each capacitors are same. So just opposite to series connection. So here V across all capacitors are same. For parallel connection, V across all capacitors are same, and Q is equal to Q1 plus Q2 plus Q3. That the charge across each capacitors are different, so the total charge is equal to Q1 plus Q2 plus Q3. Then now the total capacitor is nothing but the addition of all three parallel capacitor, and this is quite different, quite opposite to resistance series and parallel connection. So next, this one is also very important equation. We can expect question from this equation also. So this is nothing but energy stored in each capacitor. So energy stored in capacitor E is equal to half into CV square joules. So the energy stored in capacitor E is equal to 1 by 2 CV square, and here C is the capacitance, V is the potential difference. So E is equal to 1 by 2 C into V square joules. So this is very important equation. We can expect question using this equation. So now we studied the equation for finding total capacitor and also energy stored in capacitor. So now we solve the problem using that equation here. So an air capacitor of 0.005 microfarad is connected to 500 volt DC. Find the energy stored in the capacitor. And we know energy equation, that is E is equal to CV square. And here C is, so 1 by 2 into C is 0.005 microfarad 10 to the power minus 6 into V is 500 volt. So 500 square. So this is nothing but, this is 250. So this solving this, we will get 255 into 10 to the power minus 6 joules. So this is the energy value stored in that capacitor. Different across each capacitor and voltage. Potential difference is same for all capacitor value. So we have to find Q1, Q2, Q3 value. So Q1, so we have to find Q1 value, and Q1 value we know that is C1V. This is not C. This is C is equal to Q by V. So Q is equal to C into V. So Q1 is equal to C1V, that is equal to 10. C1 value is 10 microfarad. So 10 into 10 to the power minus 6 into 250. So that is given as 2500 microcoulomb. That is Q1 value. Similarly, Q2 is equal to C2V, that is 50 into 10 to the power minus 6 into 250. That is 12,500 microcoulomb. So this is the value of, so this is the value of Q1 and this is the value of Q2. And similarly, Q3 is equal to C3V, that is 25 into 10 to the power minus 6 into 250. So that is equal to 6250 microcoulomb. So this is the value of Q3. So the charge across this capacitor Q1, Q2, Q3 value we found. Next we have to find the total capacitance. So the parallel connection, total capacitance here is C1 plus C2 plus C3. Just add all three values. So that is 10 plus 50 plus 25. So that is 85 microfarad. So the total capacitor here is 85 microfarad. Next question, find voltage across each capacitor and total capacitance, and the same capacitors are connected here in series connection. So that find voltage across. So the voltage drop across each capacitor is different. This is V2 and this is V3. So we have to find V1, V2 and V3. So we know the formula C is equal to Q by V. So V is equal to Q by C. So now we have to find this Q value first. For that, Q is equal to C into V. And this is the total capacitor value and this is total voltage. And C total for series connection, that is the reciprocal of, that is 1 by C total is equal to 1 by C1 plus 1 by C2 plus 1 by C3. And here that is 1 by 10 plus 1 by 50 plus 1 by 25. So that is given as, so the LCM here is 50. So that is 5 plus 1 plus 2. So that is given as 8 divided by 50. That is equal to 4 divided by 25. So dividing by 2, 4 and 25. So 4 divided by 2, that is 1 divided by C total. And we have to find C total means that is 25 by 4. So this is total capacitor value. Now we find the C value. So now from that we can find Q value, that is 25 into 4 into V is 250. 250. So solving this we will get 1562.5 microcoulomb. So this is Q value. So Q across each capacitors here is same. So V1 that is equal to Q divided by C1. So Q here is 1562.5 divided by C1 value is 10. So the value here is 25 volt. Micro get cancelled, so volt. Similarly, V2 is equal to Q divided by C2. So 1562.5 divided by 50, that is equal to 31.25 volt. Similarly, V3 is equal to Q divided by C3. So 15625 divided by 25, that is given as 62.5 volt. So this is V1 value, and this is V2 value, and this is V3 value. So these are the voltage across each capacitor.